Good morning, students. So, chapter polynomial. This one is the revision that from R.S. Agarwal book, exercise 2A. Question: which of the following expressions are polynomial? One, x cube minus 2x cube plus x plus 7. It is a polynomial because the powers are non-negative, integral powers are present, that is 5. This one is also a positive one. 3. This one is also positive. So as this expression contains power of non-negative integral powers, therefore this expression is known as a polynomial. 2 t square 2 by 5t plus root 2. Here the variable is t, so it contains non-negative integral powers, therefore it is a polynomial. Three 5 root z minus 6. 5 z half, the square root value is power half, minus 6. So this one is what? A rational. It is a rational one. So this expression is not a polynomial. Three root over x minus 27. So x, 3 root over x, that is equal to x to the power minus x to the power 1 by 3 minus 27. So here this one also rational power. So it is not a polynomial. Next question. X to the power minus 2 plus 2x to the power minus 1 plus 3. Here this is negative integral power. This one also negative integral power of x. So this expression is not a polynomial. So when it contains a positive, that means non-negative integral power, then this expression becomes a polynomial. In this case, the variable contains rational power, so it is not a polynomial. In this case, the variable contains negative integral power, so it is also not a polynomial. Now, next question, write the degree of the following. 1, 2x minus root 5. Here, the power of that variable is 1. So, degree is 1. 3 minus x plus x square minus 6x cube. You see the variable maximum power is 3. So here degree of this polynomial is 3. Only 9. So here degree is 0. Coefficient of x cube in 2x plus x square minus 5 x cube plus x to the power 4. Coefficient of x cube. So coefficient of x cube is this one. So answer minus 5. Coefficient of x square in 3x minus 5. In this polynomial, is no x square is present, but the question is write the coefficient of x square. So answer is 0. Next question, give an example of a binomial of degree 27. So you have to write a binomial of degree 7. So in case of binomial there is 2 terms. So x to the power 27 plus 3. You take any variable with power 27 with any term. So this becomes a binomial of degree 27. Give an example of a monomial of degree 16. So monomial means only one terms. So y to the power 16. Give an example of a trinomial of degree 3. So answer, as you have to write 3 terms, that means trinomial of degree 3. So 4x cube plus 3x plus 7. So it becomes a trinomial of degree 3. 4x cube plus 3x plus 7. Next question, write a linear quadratic and cubic polynomial. So answer, linear polynomial, maximum power is 1. So 4 plus x, a linear polynomial. Next is quadratic polynomial, that power is 2. So 3x square plus 7, quadratic polynomial. And last one, cubic polynomial, its maximum power is 3. So x minus 4x cube, maximum power is 3, so it becomes cubic polynomial. Maximum power of the variable 1, so becomes linear polynomial. Maximum power of variable is 2, so quadratic polynomial. Maximum power of variable is 3, so it becomes cubic polynomial. Exercise 2b, question, px, name of the polynomial 5 minus 4x plus 2x square, p minus 2, p 0, p minus 5. So for these values, you find the polynomial of that one. So p minus 2, so in place of x write 2, 5 minus 4 into minus 2 plus 2 into minus 2 square. So 5 plus 8 plus 8, 21 answer. Next, p0, so in place of x write 0, so 5 minus 4 into 0 plus 2 into 0 square. So this 4 into 0, 0, 2 into 0 square also 0, so only 5 left, so 5 is the answer. Next, 5 minus 5. So in place of x write minus 5. So 5 minus 4 into minus 5 plus 2 into minus 5 square. So 5 plus 20, 5 4 is 20 plus 5 5 is 25 into 2, 50. Now add this 3, 50 plus 20, 70 plus 5, 75. So for these values, the answer of the polynomial, first one 21, second one 5, and third one 75. find the zero of the polynomial. So first px equal to x minus 3. You have to find the zero of the polynomial. So px equal to 0. So in that place write 0 equal to x minus 3. So x equal to 3. So 0 of the polynomial is 3 is the 0 of the polynomial px. Next, p t equal to 2t minus 3. Now p t equal to 0 as I find the 0 of the polynomial. So 0 equal to 2t minus 3. So 2t equal to 3, t equal to 3 by 2. Therefore 3 by 2 is the 0 of the polynomial p t. Three px equal to ax plus b, where a is not equal to 0. Now to find the 0 of the polynomial. So now px equal to 0. So 0 equal to ax plus b. So ax equal to minus b. X equal to minus b by a. Therefore minus b by a is the 0 of the polynomial p x. In this way find the 0 of the polynomial. Verify that minus 3 is the 0 of the polynomial px equal to x plus 3. So to prove that one, minus 3 is the 0 of the polynomial. So p minus 3 in place of x, write that value. So minus 3 plus 3, it becomes 0. Therefore minus 3 is the 0 of the polynomial. 2 by 5 is the 0 of the polynomial px 2 minus 5x. So p 2 by 5, 2 minus 5 into, in place of x, write 2 by 5. So 2 by 5, this 5 cancel 1. So 2 minus 2 becomes 0. So here is 2. Therefore 2 by 5 is the 0 of the polynomial. In this question, you have to verify this one. One and 2 are the zeros of the polynomial Px equal to x minus 1, x minus 2. Two values are given. I have to prove that both are the zeros of the polynomial. So first I take 1. In place of x write 1 minus 1 into 1 minus 2. So 1 minus 1 0 into minus 1. Any number multiplied with 0 becomes 0. So here that is 0. So 1 is the 0 of the polynomial. Now you put 2, P2, place of x write 2, 2 minus 1, 2 minus 2. So 2 minus 1, 1 into 2 minus 2, that is 0. So 1 into 0, 0, here also 0. Therefore 1 and 2 are the zeros of the polynomial. So in this we can write, therefore 1 and 2 are the zeros of the polynomial. Two and minus 3 are the zeros of the polynomial Px equal to x square plus x minus 6. So 2 and minus 3. I have to check that one, verify are they zeros of the polynomial or not. So first you put 2 in place of x. So 2 square plus 2 minus 6. So 2 square 4 plus 2 minus 6. So 4 plus 2 6. 6 minus 6 equal to 0. Now answer is 0. Therefore 2 is the 0 of the polynomial. Next, p minus 3. So in place of x we write minus 3. So here first minus 3 square plus x minus 3 minus 6. So here minus 3 square, that is 9, plus into minus minus, minus 3 minus 6. So 9 minus 3, 6. After that minus 6. So 6 minus 6, 0. So it also 0. In both the cases the answer is 0. Therefore 2 and minus 3 are the zeros of the polynomial. Exercise 2C. Question using remainder theorem, find the remainder when x cube minus 6x square plus 9x plus 3 is divided by x minus 1. So by remainder theorem you have to find the remainder where this polynomial is divided by this one. So by remainder theorem we know that when write that one px, when px name of that polynomial is divided by x minus 1, the remainder is px minus 1 equal to 0, that way x equal to 1. So remainder is p1. Now p1 equal to 1 cube minus 6 into 1 square plus 9 into 1 plus 3. In place of x, write the value of 1. That means 1. So 1 cube 1 minus 6 plus 9 plus 3. So 9 plus 1, 10. 10 plus 3, 13. So 13 minus 6, answer is 7. Hence, the remainder is 7. Now, question number 2. X cube minus 7x square plus 6x plus 4 is divided by x minus 6. Write the name of that polynomial, name it fx. So fx equal to this one is divided by x minus 6. So by using remainder theorem, I have to find the remainder. So by remainder theorem, we know that when fx is divided by x minus 6, the remainder is x minus 6 equal to 0, therefore x equal to 6, so is a 6. So now a 6, in place of x write 6, so 6 cube minus 7 into 6 square plus 6 into 6 plus 4. So multiply 6 3 times, so 6 is 36, so 36 into 6, 216, so 216 minus 6 is a 36, so 36 into 7, 6 7 is 42, so 4, 7 3 21 plus 4 25, so 2 5 2 plus 36 plus 4. Now add these three, this 6 6 12, 13 14 15 16, 1 5 minus 252. Now subtract it. So 256 minus 254, answer is 4. So remainder, when this polynomial divided by x minus 6, the remainder is 4. So afterwards you write that one, hence the remainder is